Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over how to organize the principal energy levels and sublevels and orbitals, as well as to show you the relationships between them, patterns that you should see, and how to put that together to give you a tool that will allow you to write your electron configurations without having to memorize them in order, although you probably will over time just end up memorizing them anyway. But I'm going to show you a tool that's really handy for writing the order of sublevels and energy levels. So let's get into this. The first thing we need to know is the patterns of principal energy levels to sublevels and orbitals, and relate those to each other. So I'm going to go over that first. While I'm going over that, I'm going to put together a structure that's going to help you to write your electron configurations in order. So let's get started. So the first thing you want to keep in mind is that the number of sublevels you have at a principal energy level is going to be equal to the number of the principal energy level. So what do I mean by that? So if you are at principal energy level number 1, that means you're going to have one sublevel at that principal energy level. Okay. And then at principal energy level number 2, you're going to have two sublevels because you're at principal energy level number 2. So the 2 tells you that there are two sublevels. If you're at principal energy level number 3, you're going to have three sublevels, right? And so we already know, or you might already know, that the first sublevel is the S sublevel, the second one is the P, and the third one is the D, right? So you'd have SPD at the third energy level. And you keep going. So at the fourth principal energy level, you have four sublevels, S, P, D, and F. And then you just keep going. We usually stop at F because our periodic table is limited to F, but there's no reason why you can't go further. We could discover future elements that use up or involve other sublevels, so we can keep going. So if you're at principal energy level number 5, then you're going to have five sublevels, and then you just keep going, S, P, D, F, and then what's after F? G. So G would be a hypothetical sublevel that we haven't filled up yet, right? So let's put this on the board. So the way you want to write uh, your tool here is what I'm going to start with is I'm going to start by writing the rows for one row for each of this principal energy levels. So here I'm going to start with energy level number 1, right? So principal energy level number 1, you have only one sublevel. So that would be the 1S. And that's it. That's all you have for that energy level. So the next row is the second energy level. So here I have energy level number 2, and that has two sublevels. What are they? S and then P. So S comes first because it's lower in energy, and then we have the 2P. And notice I'm writing them in a row. Okay, so first comes S, then comes P. Now that's all I have for the second energy level. Now let me make this smaller a little bit. There we go. Now the third energy level, 3, so that's going to have three sublevels. So that's going to have a 3S, a 3P, and then a 3D. So SPD, and I stop at D because the third principal energy level only has three sublevels. And notice that I'm putting the sublevels in a row here, but I'm also lining them up in columns. So the S's are lined up, the P's are lined up, the D's and the F's, those will be lined up as well. So what about 4? So principal energy level number 4 has 4 sublevels, S, P, D, and F. So we'll write those. So 4S, and then make sure I line this up, 4P, and then 4D, and then we'll have 4F. And then I just keep going. So we'll just keep going. So 5 is next, principal energy level number 5, and that principal energy level is going to have 5 sublevels. So now we're going to have to add a new sublevel, and we're going to continue with the alphabet. So we'll have a 5S, we'll have a 5P, 5D, 5F, and then after F is G. So we're going to have a 5G sublevel. And we keep going. So next after 5 is 6. So we'll do 6. And then, of course, we'll need 6 sublevels at principal energy level number 6. So that's going to be S, P, D, F, G. What's after G? H. So we'll have to fill in all the way to H. So 6S, 6P. Let me make sure this is lined up better. 6P, 6D, 6F, 6G, and then 6H. Now for 7. So we'll do 7, and then we have 7 sublevels, S, P, D, F, G, H, and then I. So we have 7S, 7P, 7D, 7F, 7G, and then 7H, and then we have 7I. And we'll do one more row just for completion. So we'll have 8. So again, that's going to have 8 sublevels. So S, P, D, F, G, H, I, and then J. So we'll have S. So 8P, 8D, 8F, 8G, 8H, 8I, and 8J. And so on. We can continue this to infinity. So now notice again, the G, the H, the I's, the J's, and so on, those are hypothetical. Those could be those could be sublevels that we fill in later, right? But this is nice to know because you could be asked a question for a hypothetical element. Like, for example, what if you discover an element number 122 on the periodic table? Our periodic table only goes up to 118, so 122, that would be four more elements. So that would be going into the hypothetical here, so we would have to use a new sublevel. So how would we figure out what the electron configuration would be for such a new element, a new discovery? Well, I'm going to show you using this. So the first thing I want to state is, again, the thing you need to know is that the number of sublevels, oops, sublevels is going to be equal to the number of the principal energy level. Now let me move this over here. Yeah, maybe put it over here. So the number of sublevels is going to be equal to the number of the principal energy level, right? So if you're at principal energy level number 1, you have 1 sublevel. If you're at principal energy level number 2, you have 2 sublevels, 3 sublevels, 4 sublevels, and so on. Okay. The other thing that we need to know is the number of orbitals at each sublevel, right? So the number of orbitals at each sublevel is going to be, so here, if and I'll write this as the how should I write this? So it's going to be the number of sublevels is going to be, let's see, 2 minus, it's going to be 2 more than the other one. So if we start with 1, right, then the P is going to have 3 orbitals. So we have 1 orbitals to add 2 to 1. That's going to be 3. So you always have 2 more than the previous sublevel. 2 more orbitals than the previous sublevel. So let me write that over here. So we know that your S sublevel, that has 3 orbitals. Okay. Oh, sorry. Not 3 orbitals. 1 orbital. I'm thinking P. So you have one orbital at the S sublevel. So every sublevel only has 1 orbital. It's just 1 S orbital at that sublevel. If you have a P sublevel, then we add 2 to 1, that gives us 3. So we have 3 orbitals. And then for the D, you increase it by 2. So add 2 to 3, you have 5 d orbitals. And then when you have F, you increase that by 2. So you have 7, you're going to have 7 F orbitals, and so on. So hypothetically, if we go to G, right, after F is G, well, how many orbitals would you predict at the G sublevel? Well, you add 2 to 7 and you get 9 orbitals at the G sublevel. So you should have 9 G orbitals. And if you go on to H, right, we add 2 more to 9, we get 11 orbitals at the H sublevel, and so on, right? And it continues. So notice that you have all odd numbers: 1, 3, 5, 7, 9, 11, 13, 15, 17, and so on. So you can predict how many orbitals you would have at a particular sublevel, even if that sublevel is never occupied by electrons, or we don't have an element that uses those hypothetical sublevels. And again, you can figure out the maximum number of electrons in each of those sublevels by noting that the number, each orbital only holds 2 electrons, maximum. Orbital, not sublevel, orbital. So any orbital, no matter what, can only hold a maximum of 2 electrons. So that means an S orbital can only hold a maximum of 2 electrons. A p orbital can only hold a maximum of 2 electrons. a D, an F, a G, an H, no matter what orbital you have, it can only hold a maximum of 2 electrons. However, the sublevel, which has that can have multiple orbitals, can have a larger maximum, right? So, for example, the S sublevel only has one orbital, so the S sublevel can only hold 2 electrons maximum. The p sublevel has 3 p orbitals. Each orbital holds 2 electrons. So that means that the p sublevel can hold a maximum of 6 electrons. The d sublevel has 5d orbitals. Each orbital can hold 2 electrons. So 5 times 2 gives us 10. So the maximum electrons that the d sublevel can hold is 10. And so on for the f sublevel. 7 orbitals times 2 electrons gives us 14. So the maximum number of electrons that the f sublevel can hold is 14. And then if we go to G, we could calculate and predict what the maximum number of electrons would be for the G sublevel. Since we predict that there are 9 orbitals in the G sublevel, then that means each orbital is going to hold 2. So 9 times 2 gives us 18. So the maximum number of electrons in the G sublevel would be 18. For H sublevel, it would be 11 times 2, which is 22, and so on. Okay, so now that we have that cleared up, let's go back to our table here. So now we're ready to use this to help us write our electron configurations. So I'm going to switch to a different color. I'm going to use red so that it's clearer. And so I'm going to draw I'm going to draw parallel arrows diagonally through my table. And what I'm going to do, how I'm going to do it is I'm going to draw an arrow that's diagonally through the 1s first. So I'm going to draw them along through these guys here and between them. So I'm going to draw an arrow through the 1s. So let's start that first. So I'm going to draw it diagonally this way. So I got that arrow there. And then I'm going to draw an arrow in between the 1s and the 2p. So in this space here, I'm going to draw an arrow diagonally and parallel. And now I'm going to draw it through the 2p here, diagonally and parallel. So I draw it this way. So notice I'm going through the 1s and then between the 1s, 2p. Now I go through the 2p. Now I'm going to go between 2p and 3d. So I'm going to draw it diagonally through the space here. So I'm going to draw it this way. Now I'm going to draw it through the 3D, and I'm going to draw it diagonally through the 3D and parallel to the other arrows as best as I can. I know it's not quite parallel. And then now between the 3D and the 4F. So I'm going to draw it parallel like that. And now through the 4F, diagonal and parallel. Now between the 4F and the 5G, and so I'm going to draw it parallel. And I keep going. So next would be through the 5G, and then between the 5G and the 6H, and so on. And so you can see the pattern emerging that if I start up here, and I just follow the arrows, I write down the sublevels in the order of the arrows. So if I start here, I start with the 1s. Now I'm going to go back to my other color, and I'll write it out here. So I start with this arrow, I write out 1s. So then it's 1s. And I have a total of 2 electrons maximum there, but we can fill that in later. Or I can fill it in now. So there would be 2 electrons there. And then now that I'm at the end of this arrow, I come to the next arrow, the beginning of the next arrow, and I go through that one, and I go through the 2s. So the 2s is next. Right now I would fill that in with 2 electrons. So that sublevel can hold two electrons maximum. And then now I'm at the end of this arrow. I come to the third arrow and I just go through and I write down each sublevel that I'm going through. I go through the 2p first. So I write down the 2p, and that has a maximum of 6 electrons possible. And then when I fill that in, then I fill in next is the 3s. So then I do the 3s, and that has a maximum of 2 electrons. Now I'm at the end of this arrow. Now I'm here at the beginning of this arrow, and I keep going. So then the 3p is next, followed by the 4s. So 3p, 6, 4s2. Right, now I'm at the end of this arrow. Now I got to go to the beginning of the next arrow. And so now it's 3d, 4p, 5s. So 3d, 10, 4p, 6, 5s, 2. That's an ugly 2. 5s2. So now I'm at the end of this arrow here. Now I keep going. So I go to the beginning of the next arrow. Now it's 4d, 5p, 6s. So 4d, where am I? 4d, 5p. So 4d, 5p, so it's 4d10, 5p, 6. Where are we? So 5s, 4d, 4d, 5p, followed by 6s. Do I have space here? Yeah, I have space. 6s2. So 4s2, 3d10, 4p6. 5s2, 4d10, 5p6. 6s2. Now I'm at this one. At the end of this arrow, I go to the next one, and I go 4f, 5d. So I'm going to continue here. So I have 4f, that's going to be 14, 5d10, 5d10, 6p6, 6p6, and then 7s2. And then I keep going. Now we're going to start to get into more of the hypothetical, right? So here we go to 7s. We're at the end, and we go to this arrow. Now we're at 5f. So 5f14, 6010, 7p6. And now here, we're at the end of our periodic table. This is where our periodic table ends at 118, but we can keep going according to the arrow. So our periodic table only has 7 periods in it, right? So each energy level in this chart here corresponds to each of the periods in the periodic table. So here we are ending at row 6 or period 6 in the periodic table. So if we're going to 8, this is a hypothetical element. So our next element, whatever we discover, we're going to start putting electrons in the 8s sublevel. So that's going to be 8s would be next. So I'm going to kind of draw a little dotted line there to represent that everything past this is hypothetical. We haven't discovered elements this large yet. But according to our chart here, it's possible. They're hypothetical. So then at the end of this arrow, we can just keep going, right? So we would draw an arrow this way, diagonally, right? And so next would be the 5G. So next would be 5G sublevel, followed by the 6 F sublevel. So again, G right here, G would have 9 orbitals, so that would have a maximum of 18 electrons. So this would be G18, and this would be F14, and then so on. And so that is how you can use this chart to help you write the electron configuration for any element on the periodic table and beyond the periodic table if you're ever given a hypothetical element to write the electron configuration for. So I hope this is helpful. If this is a nice tool, if this was really helpful for you, then please, by all means, like this video, share this video, hit that like button. Also, make sure you subscribe to my channel, hit that notification bell, and when you do, make sure you click all so you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If there's a video you want me to do or a topic you want me to cover, let me know. I would love to do that for you. Thanks for joining me, and have a great day.